focused on some specific way to update information in the model. We just saw in the previous lesson how we can import back information using using Excel. I just want to show you how we can drive the informations, how we can check, we can run like a code check on the model, and then we can create filters based on this to color the model. And I will start to introduce you how to create interfaces in Dynamo to quickly create your tools and then to distribute your tools inside your team. So let's start from the first thing. So Dynamo is already opened. Let me close this one. I was just working on something. Starting from this model, let's see what we can do. We've got some specific MAP system in this model, and we have a couple of others informations like rooms, zones, and so on. So the idea now is to use Dynamo to check the elevation, the bottom elevation of elements. So we can create specific views where we can see that, for example, we have installations above a certain elevation. So this is something that you can create very easily with Dynamo. It's not very easy to create it with Revit because you have to go section by section. You have to check the elevations, and it's not very easy to calculate this. Or you can use a schedule, but again, you have to go using filters in schedules, and that's not very quick solution. So basically, what we can do, as always, we can collect information. So we can collect a specific category of elements, going, for example, using ducts. Let's fit the screen, not center line, but we want to collect ducts. And together with this, we want to collect all elements of categories. So we have the all elements of category node. We have got a couple of ducts in the projects, and we know exactly how to extract parameter. So get parameter value by name. So right now you should be able to do this very quickly. And what we need exactly, it's the bottom elevation of each element. So as you can see, we don't have exactly the bottom elevation of the element. We have the center line elevation, which is the offset against the reference level. So what we can do, we can use the offset information and the height information, which is the height of the section of the duct, to calculate what is the bottom elevation of each element. And then we can run a clash, or we can run just a check on the model to understand if this value, if this elevation is acceptable or not. So let's do this check quickly. We need actually two informations. We need the offset information, which is an instance element, an instance parameter, and we need the height information. We can't use the size because the size is actually a string. So we have to do some intermediate check on the string to be able to extract just the height from this. But because we already have the height information, we can just extract that one. So let's do that, writing the names of the parameter that we need. So we need the offset, and we need the height. So if you remember, we can use two different kind of syntaxes. We can create a list with this, and we can create, then we can have a list of these informations, or we can use what I'm suggesting to you. We can use this other syntax. So we can create actually manually a list of elements. So the first one is the offsets, and the second one is the height. And then we need to close it. So this is actually creating already a list for us. So we can then connect these elements, and because we need to run this list again, each one of these elements, we need to change the lacing setup of this node from shortest not to longest, because the longest will not get the right information, but into cross product. So we know that actually all of these elements will be checked against these two. So I just used the wrong way to write it, probably. Heights. And that's it. So the elevation of the elements, it's in millimeters, and the height information, it's not in millimeters. And we can easily understand, because this is 0.9 is 0.8 or something very very weird as a number. So we can easily understand that this number is in feet, is not in is an imperial display unit, it's not in metric display unit. So we need to convert this using the conversion value. And to do that, we need to do something that you should already know. It's to transpose this list into another list where we can get this only this information, and we can convert only this information and not the first one. So we can use the transpose, or we can use another system, which is the get item at index. So we need to get the item at a specific index, which is the number 1, but is inside the nested list. So it's not the number 1 of the main list, but is the number 1 of the nested list. So if we are going to use just number 1 as an index, we will get only this number. But if we use a level, a deep level of the element, we can reach the right one. Just we need to remember to keep the list structure. So let's do this job in a proper way. And why it's not working? So we should get the lacing in the right way. So that's the number that we need exactly to extract from this level to get the right number and then convert this number. So you need to understand the real use of levels. In this case, you can also get the same result just changing the lacing, because the lacing will go inside the first level of this list. But if you have more than one level inside the list, we only have 2 levels here, so we can do that. But if you have more than 2 levels in your list, then you need to go and use these levels. So, oh, I think that Jose, can you please help me to get Folkert into the Zoom meeting? You will probably need to send to him the right link. I don't. Let me check. Let me pause.
Let me check. But the link is the same as Saturday. I don't think it's a problem. But I will send to Folkert. I got his email, so I will send to him. Okay, no worries. Straight away. Okay.
Okay. Okay. Thank you.
Thank you.
Bye. So You need to play a little bit around this. Oh, thank you for the suggestion anyway, for the alert. So you need to play around the lists to understand how to get this information. You can get the information in many ways, and it depends on how much these lists are nested one inside the other. So let's extract again also the first number in the same way, so we can compose again later the right list. So we can get with a copy paste the same elements. So, and we can just convert these informations from feet into, let's say, millimeters. So the final number will be exactly what we need. So the 0.9 is 300 and the 0.8 is 250. So we can easily understand now that this is the right number. I'm sorry for the muezzin, but I'm in Turkey right now, so it's time for prayer, but it's just a couple of minutes, don't worry. So what we need now actually is to remove this value from the value of the center line of the element. But we don't need just to remove the entire value, because remember, the value is half of the size. So first of all, we need to divide by 2. We need to divide this value by 2. And we can do that in many ways. We can do that using the divide node, if you don't remember, or we can use again the code block. So we can say that we want to divide a value. We can call the value x, for example, and we want to divide this value by 2. So as you can see, the code blocks are always really, really, really powerful. So we got the 150, which is exactly what we need. You can imagine that we could also connect this before the conversion, that will get exactly the same value, but it's just not very easy to understand. So first of all, I like to convert the value, and then we can use the division. You know that also you can use a conversion value. So if I'm not wrong, is 308. Let me check on the internet. Feet to millimeters. I always forgot the real number. Yeah, it's 304.8. So you can say also that you can, instead of using these convert units, you can use 304.8, and you can say that you can multiply this x value for a conversion, or for a factor, if you want to do, if you want to name it factor, and then you will get exactly the same value. So if you want to convert into meters, you have just to say that you want 30 points. So if you want to convert into centimeters, then you need just to move this this value from here. But that's maths, it's not Dynamo. So we already have the value of the elevations in millimeters, so we don't want to use meters. We just need now to remove from this value, and to do that we can definitely say that we want the elevation, for example. It's just a name. You can name it as you want. It's just a name. So we need to remove from the elevation the half section. So I like to name it in a proper way, and if I'm going to check the script after a couple of weeks, I remember how to what's the matter of that node. So let me connect this to this, and we've got the final result. So perfect. So that's what we want. and this is the final result. And actually, this is pretty it's parametric. So whenever we are going to move something in the model, we know that we have always the right information at the end. So let me have a quick rearrangement of the elements. So let's see that as always, this is an input and this is the category. And for me, it's always gray. So this is the extraction of the informations. So I can just move a little bit this one here. So for me, all of these are extract offsets. And this last one for me is just calculate the bottom of that. So it's pretty easy, pretty simple. Let me save this like lesson 07. Okay, perfect. So what we need now, we want to know now what is exactly the value that we want to check. So we want to create a red color whenever we find something that is less than or greater than. So to do that, we need one more input actually. So we need a value that we want to check. Let's say we want to check 2.5 meters, because most of the times in the specifications you don't have millimeters, but probably you have centimeters or meters for these kind of things. So we want to check 2.5 meters, and we can actually create a comment here and say this is the elevation to check. And we can say that this is in meters, just to remember. So again, this is still an input, so we can select this group, then we can click on Shift, and then click again, left click on the node, and then right click on the node and say Add to Group. So we know that this is now part of the inputs information. So let's name it again input. Okay, fine. So definitely now we need to compare this value against this value. And to do that, I would like, first of all, to round this value using a round formula, so a round function. So the round function is accepting, let me check, sorry. Why is the height in the wrong way? Because in Revit it's in the right way or not? So the height actually in Revit, it's in the right way because it's Revit that is changing that value in the interface for you. But the core of Revit is working in imperial information. So that's why you have to, because Dynamo is going directly to the core of Revit, some information will be in the right way and some information will be in another way. That's the strange part of Revit. It's not actually Dynamo. So sometimes you have to look exactly what is the kind of number that you are receiving from the, let's say from the database of Revit. So you need to check if you are getting millimeters or meters, which is the project value, or you are getting the core value of the information. And that depends on one thing actually. If you remember, Revit was split into 3 different Revits. That was Revit Architecture, MAP, and Structure. And then at a certain point, probably 2 years ago, 3 years ago, they tried to put everything together. So the MAP part, for example, was working in imperial units, and the architectural part was working into another way. So the idea is now that we have like a collage, if you want to use a French term, of things, and sometimes you can find imperial and sometimes you can find metric. So it's just something crazy, but you have to work with that. So a quick check from the beginning that will give you just the right information straight away. So right now we have an elevation, and I don't like this elevation. It's 2888.4. I don't actually like that. So I prefer to convert this number into something that can be a little bit more easy to understand. So I would like to use math using the capital M, which is the name of the library, the mathematical library, and I would like to use the round function. So the round function can be used in two different ways. And the first one is just to use a double number, and the mathematical function will just round using the number of decimal position that you already have. Otherwise, you can use the number and comma the number of values that you want to use after the comma. So using that, you can see that we just use two numbers, or for example, three numbers after the comma, or four numbers after the comma. It depends. So some of them will just have these numbers, some of them won't have these numbers. And if I'm going to use this value, it will just round at the closest integer number. So we can actually use this to understand what we need. And of course, because we need to use meters, because we have a meter value, we can either convert this into millimeters, or we can convert directly this one into meters. So I would like to convert this value, this final value, into meters, just saying that I want to divide this number by 1,000. So that's the final value that we have at the end. So you can decide to round the first number and then divide by 1,000. But if you just insert a new couple of brackets, round brackets, you will get a new rounding. So be careful when you start to round something. Just you have to understand where to place the right brackets for the before using a function, because this will change a lot the final result. So my idea now is to round the final number, the entire number, using just two numbers after the comma, so two decimal numbers after the comma. So that's something that I can like to use at the end. So it's pretty close to the value. It's not the exact value, but we don't need the exact value actually. So just 1 millimeters or 1 centimeters, it doesn't make that much the difference. But if I want to export this value, then probably in Excel that will be a little bit better to see. So finally, we need to check this value against the first one. And to do that, we can use again a node, which is this node, which means less. So we can check if X is less than Y, or is less or equal than Y, or it depends on what kind of check we want. We can check if X is greater than Y, or X is greater or equal than Y. So I want to exclude from this, from the list. I mean, I want to understand which one are less than the value that we want to check. So I'm going to use the less symbol, you can use this symbol using the nodes, or you can use the symbol directly into a code block, which is what I'm going to do. So I want to check if the X number, let's say this is X for me, is less than the Y value. So my Y value is exactly this one. So if a number is less than the value that I'm checking, I'm gonna get a true. So that means we have an issue. If the number is greater than the Y value, I'm getting a false. That means that value is correct. So depending on which kind of symbol you are using, you will get a value or another. So I can see from a quick search that everything is just greater. No, we have some true value. So that means we have something that is less than. So after this element, so after this check, we have a list of true and false. And to make a selection of element based on the result of this value, we can use another really powerful node, which is filter by bool mask. The bool mask is filtering whatever is true or false from a list. So the mask is actually the list of true and false, and the list is the list of elements. So we want to know which elements are in the list of issues. So we need to connect the elements right to the filter by bool mask. So in the in list, we will get all the true. So all the elements that are not correct, because this is how we are working on this. So if we want the exact different opposite, complementary, we need to change into greater. So as you can see, it's just the opposite. It depends on how you want to control. So from this list, I'm taking the in value, because the in value is actually what is going to be. I need to check why it's not going to filter the list. I have probably some null value. Yeah, I have some null value. I will check this one now. Let me try. Anyway, so what we need now is exactly to understand which one is the true. So we need to remove the null value from here, and I have to understand why we have a null value. 716, 716. So this is also a way to check the model. 716. Oh, I can see here that we have some null value, and those are probably the round ducts, because the round ducts, they don't have actually a value for the height. They just have a diameter, for example. So we need to find also a way to select only the rectangular ducts. I'm not going to focus on this one right now. I just want to show you how we can filter elements from here. So I will remove the null value, and you have actually a couple of nodes to do that. For example, in the Archilab package, so we can clear a list of null values just using this Herculab list. And now we have, as you can see, the 719 values, and we can actually connect this into this, so we don't have any more the value. So this is actually the list now of elements that are less than the other value. So what we can do now with this list, we can use the set parameter value. So we can, for example, write into a specific parameter, for example, the comment. So let's see if it's comment or comments. It's comments with yes. We can write something like not verified. So we can write this value just inside the elements. And after we do this, we can just create a new filter here where we can say that we have duct not verified, and we can say that we want to apply this to ducts, and we want to check if the value of comments is equal to not verified. So let's say okay. And we can actually color by red and say okay. And we can give some transparent value. It depends on how you want to color these elements. So we have immediately the idea that these elements are in the wrong positions. So we know that we have to look into these elements because they are probably going to create a specification issue on the project. And you can run these checks quickly if you have a template and you just use the same script for other categories. That will be very easy for you to check and to understand how to verify a project. You can verify, for example, if rooms that are part of a specific department they already have the right square meters, for example, or you want to check, for example, if you have the right common area spaces or you have the right area per person. So you can run many different kind of checks on the model using just Dynamo. So if you remember, now you can put together the bricks. So you can extract informations, you can change informations in Excel and bring back those information into Revit. Then you can build dashboards using these informations, and then finally you can highlight this information in the model using the same script of Dynamo. So it's not just using Dynamo for geometries, because in my opinion, this is the smallest part of Dynamo. So you can use Dynamo for many things. And one of the most powerful things is just managing data, because data, you probably already know, it's the new petrol of this century. So this massive use of data in the model is useful only if you use data to do something, because otherwise you have only a 3D geometry, so without any kind of life inside. But if you start to compose these numbers, if you start to use this number for presenting dashboards to find issues in the model, then you can use graphics informations like filters, like colors, to expose your design intent to the client, to the customer. So that's one of the way you can use data and Dynamo together with Excel or dashboards. So what if I want to avoid to open, for example, Dynamo to run a script? So we have a couple of ways to do that. So let me keep this one as an idea, and let me save it with another name. So let me save it with lesson 7.1. And I will show you now how we can use Dynamo to build simple interfaces that later on can be used with Dynamo Player. So I will introduce you Dynamo Player as well. So let me, for example, yeah, we can still use this one, and instead of going to calculate everything, I will simplify a little bit so we don't get this this error. I will just check the offset value, and let me remove this one, and I just want to check this. So I don't need anymore this to be cross products. I just need this to be the offset value, so not anymore a list of elements. Of course, I don't have anymore an item 1, and I just have this one that I need to convert into meters. So I don't need this conversion anymore. I can just remove, and everything is here already. I don't need to clear anything. I just need this to be connected to this value. Perfect. So we have now the elements, and we know that these values are just, we need to divide this x by 1,000. Well done. So those are all the elements in the list number 0 that are less than 2.5 meters, and those one are the ones that are not. So as you can see, the element is still working. I can prove you that if I'm going to change this value, some of them will change probably. So some of them will be, I have to reduce this. So some of them will go probably to change values. Because I can remove the mask, and then I can recreate this. Let me go Control Z, Control before applying that. So I can run now with a new number, and no more elements will be actually not verified. But if I'm going to put this to 3 meters and I'm running again, you can probably see that now most of the elements are less than, let me do something like that, 4 meters. Oh, I have probably removed the filter, that's why. So let me add again the filter, new filter, ducts, comments equal to not verified. That's okay, okay. And filters, add, oops, duct, override, red, and solid again, and that's it. So as you can see, most of them are not verified anymore. Okay, so let's see now how we can build this interface. So first of all, remember I showed you how to download a new package package, and we used Archilab Mandrill to do dashboards. We need to download another package to build graphical user interfaces in Dynamo, and this is called Data Shapes. I've already downloaded, so it's just right here, but I will show you once the server is synchronized that you can start to write data, and the second one is data shapes. It's another one, another package that you should have in your list, because it's really powerful. So what is the basic idea of data shapes? You have couple of UI nodes that you can compose into an input form. So this is actually the latest result. So starting from this, you can start to link a couple of inputs here. So the description of the UI. So for example, we can say that is a string. So this is a tool to check duct elevation, for example. And you can connect a logo of your company, for example. So otherwise you will get the default value, the default one. You can customize the text of the push button. I will say just OK, for example. And here we are going to connect now the inputs. You can also create a small HTML file with a help, and then you can click this one. You can have a cancel button, which is optional, and default value is null, so it's not visible, but you can get a cancel button, for example. So we can say cancel, and we can connect to this. We can define the maximum height of the window and the width of the window. Otherwise, you have just the normal value. We can get that, and then we can start to collect the input elements. So if we check these values, we have basically two inputs. The first one is the category. The second one is the value that we want to check. So the first one is what is called a drop-down menu. So we can get a drop-down UI input. And the second one is just a number, so is a text value, is a text, what it's called text box. So we have the text box value here. After that, we can say the input name is category. And we need a list of categories that we can just get directly from the data shapes, because we have a list of categories. And we need actually the category names as a key and as a value from the for the drop down. And then we need the text box. The text box is actually, we can say, the elevation check. And we can say that the default value, it's probably, let's say, 2.5. So after this, we can collect all together these elements into a list of inputs using the list create. And we can connect finally this to the inputs. So let's run now this script, the last element we need is a Boolean node to say that we want to create the GUI. So let's say true and run the script. So nice to see that we have now a small interface that is running probably on top of Revit. So you will never understand that this is Dynamo, and is easy to use for someone else that just needs to check something. So we can choose the category here now. So we can say that we want ducts, and the elevation is just the value that we use as the default. We have the description right here, we have the cancel button, and we have the OK button to execute actually the script. So exactly what we used to put into our workflows. So if we click cancel, of course, this won't run actually. But if we click now again and we say, okay, we want to use ducts and say, okay, we have a couple of outputs from this node. So we know that was ran because it's true and wasn't canceled. So we know that we have from the first list now, we have the two inputs that we actually need to execute the rest of our script. So the idea is to collect, for example, the first element, and we can use this notation to get the first element of a list, which is the ducts value. And we can extract, for example, the 2.5 from the same list. And we can then remove this value from here and just say, I want a category by name, because we have a name now. And I want to convert this 2.5 that right now is a string into a number. So number from string. Oops, it's not this. Number from string. So we have 2.5 now, which is different from this 2.5 because this was a string. And we have a category, which is different from this because this was a string. So remember that whatever is actually an output of this node is a string. So you have to work on that to convert, for example, a number from a string or a category from a string. So just follow me. I'm connecting now this category directly to this element of category. So I can remove this. And I can connect the 2.5 directly to this node because this is what I want. And if everything is correct now, I can just Control Z. Let me check if I still have the filter. Oh, Jesus. Filter, duct, okay, solid, and okay. So let me select, for example, all the ducts. I will just remove now the comment from here manually. Okay. So I'm going to execute now this script using the interface. So let me reset this one. First of all, running into false, and then running again into true. So I have my interface. I can choose my depth value. I don't understand why there is still some duct. I'm gonna call you like comments duct, and I want to change this duct into, I want to remove the filter duct. I don't know why it's not coming. Anyway, doesn't matter. So 2.5, let me check ducts now. Let me select ducts. Let me choose 2.5 and let me click OK. So the problem is that is actually right now running again to the same value like we used before. Let me just select this and say put to true as well. So we can reset actually. Control Z. And now that we know that the script is working, I can save this script. And I can save as this script saying that this is duct elevation. So I can close Dynamo. And I can say to Dynamo Player, which is actually something that you can use to run script without opening Dynamo if you have inputs in Dynamo. So you can just say to Dynamo Player to find where are your scripts. And now, for example, I have scripts on my desktops. You can select the script that you want, and then you can, if you have an interface, you can run the interface without opening Dynamo. So right now is reading the script. Now I have my script here and here is still running. I can choose ducts, for example. Again, I can choose the value 2.5, let's say 2.8, and let's click OK. Boom. Just a second and you have the script executed without using Dynamo. And I can run again the script and say this time is 3 meters. And again for ducts, for example. And I have new ducts coming. Or I can run again. Let's say I'm not going to do for ducts, I'm going to do it for, let's say, probably pipes. So I want to do pipes 3 meters and say okay. So of course I need a new filter for that, and I can say that I need pipes not verified, and I can say just find pipes and check the comments for pipes where is equal to not verified, and add this one. Let's see, we want to use a different color. Let's use the orange and say okay, okay, and I will probably find some pipes with this number. So quickly, easy, you can apply this in whatever view you need, because this is actually part of Revit. So you can use, you can open a floor plan and you can apply again the same filter, but definitely I'm not going to show you how to do it in the plan or other views, because that's just Revit. There is a way to automate also the creation of filters, view filters. And I will show you this in the next lesson. So I'm going to show you how to create automatic filters without opening even the interface. So at the end of the day, you can just choose the category, you can choose, for example, the color that you want to show, and then you can just run the script and color whatever view you want to color with that filter. So it's pretty amazing what you can achieve just using a little bit of automation. And if you have your tools in your pockets, you can see that you can gain a lot of time during the design process, because that's pretty easy. You need just to build the script one time, and then you can build your own interface. And then once you need it, you can open Dynamo Player, and then you can run it. That's it. So, and without you, and with you, all the people in your team, even if they don't know how to use Dynamo, they can use your script, because you can just place your script in a network folder, and then you can say, oh, there's a new script there. You just need to play it with a small, probably, document explaining how to do that. But you can keep the control of your workflows without people touching that. And that's the first step for you on how to automate things in Revit. And that's something that you can do actually right now only in Revit. There's no other software that you can automate in this way, because most of the things that you can find around, like rhinoceros, you can just automate shapes. You can just automate, yes, extraction of information, but nothing is related to the real design process, the real extraction of, for example, layouts or sheets or schedules from the model. So that's the only thing that I think can differentiate Revit and Dynamo from other platforms. So that's everything for me today. I hope you enjoyed again the lesson, and we will see again on Friday for the latest lesson. So if you have any kind of question, just let me know. And if there is something that you would like to see in the next lesson, just let me know by tomorrow, so I can prepare specific thing to show you. So thank you, and see you. Bye-bye.